Okay, children. So coming to metals and non-metals, we discuss some important questions. Metals and non-metals, some important questions. First question. Yesterday we discussed, children, so that is the continuation. What are alloys? How are they made? First question, children. What is an alloy? How are they made? Children, what are alloys? What are alloys, children? Homogeneous. Homogeneous mixture of two or more metals or non-metals. Children, homogeneous mixture of two or more metals or sometimes better with non-metals. How are they prepared? Means, suppose two metals you want to mix. Suppose you want to mix two metals. Okay, children. First they have to be heated. Children. First they have to be heated. Okay, on heating, these two metals will melt. After melting, mix them. After mixing, cool. That's all. First you heat both the metals. They become liquids. Liquids, both of them they add in each other. Then you cool it. Okay, that is how you will. And some of the examples of the famous alloys. Give me some examples of alloys, children. Can anyone give what is the composition of steel?
Carbon and iron.
Iron plus carbon. Brass, copper and
Copper and tin.
zinc. Bronze, copper and
Copper
tin.
and
Solder, lead and tin. Stainless steel, iron, carbon,
plus copper.
chromium, nickel. What is the difference between stainless steel and normal steel? Stainless steel do not undergo corrosion.
Corrosion.
Stainless steel do not undergo corrosion. Stainless steel do not undergo corrosion. Okay, children? So stainless steel do not undergo corrosion. Next question. Okay. What is meant by corrosion? Any two methods used to prevent corrosion. What is meant by corrosion? Children, can anyone define what is corrosion? It's also there in chemical reaction. Oxidation of any metal. Oxidation of any metal in presence of air and moisture. Oxidation of any metal in presence of air and moisture is called corrosion. Oxidation of any metal in presence of air and moisture is called corrosion. Oxidation of any metals in presence of air and moisture is called what, children? Corrosion. Oxidation of metals in presence of air and moisture is called corrosion. Okay, children? So silver, if you see, it reacts with sulfur to form black silver sulfide. Okay, suppose you take copper. Copper, it reacts with carbon dioxide to form green copper carbonate. Green copper carbonate. Green copper carbonate. Suppose iron is there. Iron reacts with oxygen to form, that is rusting, of course, Fe2O3. Okay, Fe2O3. What are the methods to prevent corrosion? What are the methods to prevent corrosion? Oiling, painting, greasing,
Anodizing.
anodizing, galvanizing, chrome plating, alloying. All these are the different methods of prevention methods of corrosion. What is corrosion? It's corrosion. What is corrosion, children? Oxidation of metals in presence of air and moisture. Oxidation. Silver will become black silver sulfide. Copper will become green copper carbonate. Very famous examples in the textbook. Children, please remember. Next week. With the help of suitable example, explain the ionic bond is formed. State general properties of ionic compounds. One example we have to give the formation of ionic bonds. One example. Okay, which example will give, children? Shall we give sodium chloride? Yeah, sodium chloride will give, children. So sodium chloride. So sodium chloride example I am giving, children. Sodium 2, 8, 1. One extra electron is there. It gives one extra electrons and forms sodium plus 1. 2, 8. First step 1 now. Second one is chlorine. Chlorine will take 2, 8, 7. It is in need of 1 electron to become octet. It will take 1 electron and become Cl minus and becomes 2, 8, 8. Now, sodium, which is having an extra electron, chlorine is in need of 1 electron. This electron comes here and Na will become plus. Put it in curve brackets. Cl is 1, 2, 3, 4, 5, 6, 7, 8 minus 1. Put it in square brackets. 1, 2, 3, 3 marks. 3 marks. Okay. So what are the differences between ionic and covalent compounds? What are the differences between ionic and covalent compounds? Very, very important question. What is the difference between ionic and covalent compounds? Ionic bonds are formed by transfer of electrons. Ionic bonds are formed by transfer of electrons, and covalent bonds are formed by sharing of electrons. Covalent bonds are formed by sharing of electrons. Okay, children? Covalent bonds are formed by sharing of electrons. Ionic bonds are formed by transfer. Covalent bond is formed by sharing of electrons. Next, ionic bonds, because they have strong electronic force of attraction, they are good conductors of heat and electricity. They are bad conductors because, children, ionic bonds have ions. Covalent bonds don't have ions. Ionic bonds have ions, so they're good conductors of heat and electricity, and they're bad conductors because covalent bonds don't have ions. Ionic bonds have high MP and high BP. Why, children? Because they are held by strong interdynamic force of attraction, and they have low MP and low BP. Why low MP and low BP? Covalent bonds are weak. Covalent bonds are weak. Ionic bonds are very, very strong, children. That's why to melt them, we require high melting point, high temperatures. And generally are solid, children, and covalent bonds are generally liquids and gases. Ionic compounds are soluble only in polar solvents. Why? Because they have charges. Ionic compounds are soluble in polar solvents, and covalent bonds are soluble in non-polar solvents. Why? Because covalent bonds don't have charges. That's why they are soluble in non-polar solvents. Ionic compounds are soluble in polar because ionic have charges, polar have charges. Charges to charges, you can dissolve in each other. Ionic compounds are soluble in polar solvents. Okay, next. Next. So, children, what they're asking is, children, Rima maid fainted in her house. Rima took her maid to doctor. After checkup, doctor found that suffering from anemia. Doctor advised to take vegetables and fruits rich in iron. Doctor gave her some folic acid tablets which contain iron sulfate. Rima helped her maid financially also. What values distributed? Deficiency of which metal causes anemia? Deficiency of which metal causes anemia? Iron. Iron. Deficiency of which metal causes anemia? Iron. Okay. And what is the formula of folic acid? What is the formula of folic acid? Iron sulfate. What is the formula of iron sulfate? Fe.
FeSO.
Folic acid is FeSO4. Folic acid is what, children? FeSO4. Okay, children. Iron sulfate. Okay, children. You are able to understand. So next one. Next. Next one. While gold and silver are often used in jewelry, while iron and silver are often used in jewelry. So, children, because many people will say many reasons, children. You write 3 to 4 reasons, whichever they want, they will have, children. Number one among them is iron and gold and silver are used in jewelry because they are least reactive. They are least reactive. They do not corrode, and they are lustrous. They are lustrous, and they are malleable and ductile. You write all these reasons, children. Whichever they want, they will correct, children, because we can't say. But the best one is least reactive, children, because they are least reactive. They don't affect our skin or our body, children. In fact, they are good for our health, children. Okay, gold and silver are used in jewelry because they are least reactive. They do not corrode, and they are lustrous, and they are malleable, and they are ductile. Why hot water tanks are made up of copper? Why hot water tanks are made up of copper? Next question. Why hot water tanks are made up of copper? Why, children? Because it is present below hydrogen in reactivity series. If you see in reactivity series, it is present below hydrogen. So normally metals, when they react with water, they liberate hydrogen gas. You all know that. Metals with water gives hydrogen gas, but if copper is present below hydrogen, so it won't liberate hydrogen. It won't liberate hydrogen from water. Why? Because it is less reactive, and also number one, they are good conductors. Copper is a good conductor of heat and electricity. Copper is a good conductor of heat and electricity. These are the best reasons. Below hydrogen it is present, won't liberate hydrogen when react with hot water also, and they are good conductor of heat and electricity. In fact, they don't react with water. Copper don't react with copper, they won't react with water. We have already studied that. From lead onwards, metals do not react with water. From lead onwards, metals do not react with the copper. Next one. Yeah, children, if you know the answer, you let me know, children. If you know the answer, let's see here. A non-metal A, largest constituent of A. Can anyone understand what is largest constituent of A? Nitrogen. Okay, and when heated with hydrogen, what you will get? Nitrogen plus hydrogen, what do you get?
NH4 ammonia.
NH3 ammonia.
H.
Nitrogen plus hydrogen, you get ammonia. Nitrogen plus hydrogen is called ammonia. Okay, and it gives a gas B. What is the gas B? Ammonia. It gives an oxide C. On heating, nitrogen on heating with oxygen. Nitrogen on heating with oxygen, it gives a gas. It gives a gas. What is the gas? NO, nitrous oxide, nitrous oxide. Okay, children, nitrous oxide, again when you react with oxygen, what do you get? Nitrogen dioxide, nitrogen dioxide. Nitrogen dioxide, when you mix with water, what you get? Nitrous acid, HNO2, nitrous acid. Okay, children. So this is the reaction, children. Next one. Reactivity of aluminum decreases if it is dipped in nitric acid, children. Why, children? Reactivity of aluminum decreases if it is dipped in nitric acid. So question is, why does the reactivity of aluminum decreases when it is dipped in nitric acid? Nitric acid is a
Strong oxidizing agent.
strong oxidizing agent. So it makes aluminum oxide layer on aluminum. It makes aluminum oxide layer on aluminum because nitrogen oxide is a nitric acid is a strong oxidizing agent. Carbon cannot reduce the oxides of sodium or magnesium. Carbon cannot reduce oxides of sodium or magnesium. Do you know why, children? Carbon cannot reduce. Carbon cannot remove oxygen from sodium and magnesium. Do you know why, children? Carbon cannot remove oxygen from sodium and magnesium. Do you know why? Because oxygen has more affinity to sodium and magnesium. Why? Because sodium and magnesium are more reactive. They hold them tightly. They hold them tightly. Okay. Sodium and magnesium hold oxygen tightly. Carbon cannot reduce them. Carbon cannot reduce because they are highly reactive. You cannot reduce. NaCl in solid state do not conduct electricity, children. Take solid NaCl and pass current it home. But if you mix in water, it conducts electricity. Why? In water, sodium chloride decomposes into Na plus and Cl minus ions. When you mix in water, sodium chloride decomposes into ions. When you mix in water, sodium chloride decomposes into ions. And therefore, ions are responsible for conduction of current. Next, iron particles are often galvanized. Why, children, anyone?
Prevent
To
corrosion.
prevent rusting.
To prevent rusting. To prevent rusting. Iron particles are often galvanized to prevent rusting. And children, please write reaction also. Fe plus O2 is Fe2O3. Galvanization is coating of zinc. Galvanization is coating of zinc. Next, metals like sodium, potassium, calcium, magnesium are never found in free state. Why? Because
They are highly reactive.
very good. They are highly reactive because they are highly reactive. Metals like sodium, potassium, calcium, magnesium are on top of the reactivity series. The elements which are present on the top of the reactivity series are highly reactive, and therefore you will not get them freely in the nature. If you want freely in the nature, what are the elements you get freely in the nature? Gold, silver, platinum. They are freely in nature because they are least reactive. They are present at the bottom of the reactivity series. You will get freely in the nature. Freely means not a free of cost. Free in nature means they do not. They will be as it is like metals you will get without salts. Let's next. Okay, children. So metals and non-metals, most of the questions I did with children. Tomorrow we will start compost some important questions.